going to look at is all right. First thing we're going to look at is the red line. Okay. I think they both have a common midline of y equals 0. Would everybody agree with that? Y equals 0 goes straight across. That's the common midline. They both also seem to have a range of -1 to 1. That would indicate an amplitude of 1. You good with that? Next thing, one of them is a sine graph and the other one is a cos graph. How do I know that the red one is a sine graph? Okay. Now, the deal is it doesn't complete a full rotation until what happens? When does it complete its? When does the red line complete its first full rotation? We said 4 pi. All right. Now 4 pi, is that longer or shorter than usual? Exactly. All right. So what I'm thinking right now is, if my pen would get back online, it would be grand. All right, guys, look at this. Shh. Ready? Look. Shh. It goes all the way like that. You see that? On its way up. One, its period is 4 pi. That's twice as long as usual. Okay? Now, for argument's sake, we all know it's sine, don't we? We all know that the amplitude is 1. If I said 2x, that would be twice as quick. We want twice as long. What'd you say? A half. Exactly. So we're going to go for a half. Is that cool, you guys? Same. Means the same thing. Now, next one. Next thing we're looking at is the blue graph. Okay? How many rotations of the blue graph occur within 2 pi? All right, there's 1. 2. Within 2 pi occurred 2 rotations. So what does that mean? Y equals 1 cos. Is everybody happy with 1 cos 2x? All good? Okay. Now, next thing. The curves have a common maximum after pi radians. At what point will the maximum next coincide? Okay. So this is difficult, all right? So, do you know what maximum means? What does it mean? Huh? Yeah. When are they both at the top of the mountain at the same time? The red mountain and the top of the blue mountain coincide once, which is called a maximum at pi. Sorry? And it doesn't happen again. Okay, so we have to figure out when we think it's going to happen again. I would say it's going to be 5 pi. Now, do you know a good way? No good way of checking that out. You could try your calculator. Okay, look at this. Okay, you could throw into your calculator like so. Okay, now use GX and FX. Ready? So look at this. What do we know FX is? For argument's sake, this one's FX. And this one here is going to be GX, right? We know both formulas, which is pretty good. If you stop the whistling, that'd be great. Concentration-wise, it's not easy to concentrate on this stuff. Okay. Everybody happy with sine x over 2? Okay. And is everybody... I'm going to have to do it... Oh, we have to do it in radians. So, go back. Seems to be, doesn't it? Okay. Angle unit, radian. Let's try this again. Sine. We're going to do a 0.5x, which is a half x. Is that okay with you guys? Okay. Exactly same thing. 5x is cos 2x. Now, this will verify what you're thinking. Okay, here's what we're going to do. We're going to start at 0. Okay, who says do you think it happens at 5 pi? Okay, so here's what we're going to do. We're going to start at 0. So I go back again. We're going to start at 0. We're going to end at 5 pi. Step of pi. Great when you're finishing my sentences, because then we'll know for sure. What should happen? Both y values should be exactly there. Same. And they should be both located at what number? They should both have a y value of 1 at the same time. So we're looking for both y values to be 1 at the same time. We're going to go through. There it is there. 5 pi. So lads, what you're looking at is this here. I'll make this a lot larger, okay? Does everybody see this on the graph? On the calculator? So what I'm checking out is that one of them's at 0 and the other one's at 1. One of them's at -1 and the other one's at 1. This one was at a minimum and this one was at a maximum. This one was going through the x-axis when this one was still at a maximum. Only here are both of them at a maximum at the same time. Okay? I'm going to rub that out. And basically, that's how we know it was 5 pi. Essentially. Okay, lads. First of all, how do we know it's a cos? Perfect. Next thing. What's the middle of 10 and 40? What's the middle of 10 and 40? 25. Straight away, you know your A value is 25 because 25 is the midline. Everybody cool with that? Anybody tell me what the B value is? What's your amp? No. It's 15 above 25 and 15 below. So what's your B value? Huh? 15. Is everybody on board with that? Those two so far? Your amp being 15 and your midline being 25. Next thing, how many rotations do we do? Now, what was that? Oh, yeah, we have it here. It's grand. We're going to look for how long it takes for one rotation. Does that make sense? Let's figure it out. You're on your top and you're on your way down. When does that next happen? 12. This means your period is 12. What's the formula for period again? 2 pi divided by c equals 12. How do I find the c value? Bring the c up and the 12. What's 2 pi divided by 12? Huh? Yeah, your c value is pi over 6. Do I have enough to make this equation now? So what do I need to put beside the 15? Anybody? Cos what? Cos pi over 6 times t, isn't it? Yeah, t is time in months, exactly. We all good? Now, lads, I've successfully found out what A, B, and C are quite quickly. That's good for me. Happy days, all right? Now, what are we going to do next? What does one from me next? Over a 3-year period, how many times would the population be exactly 25,000? Well, that's pretty handy. 1, 2, 3, 4. Do you know what? It actually wants this to go all the way to 3 years, which is how many months? So we're going to have to extrapolate this. So, oh, I see. Hey, listening? It happens twice. It happens twice in a year, doesn't it? So I'd expect it to happen 2 more times. From in the 3rd year. See the way it happens twice in the 1st year, twice in the 2nd year, and then it should happen twice in the 3rd year. Is that all right? So what are we expecting the answer to be? 6. Happy days. Oh crap! I paused all this and I didn't record any of it. No, it didn't actually. We're good. All right. Next thing. Still running, but it says it's paused even though it's not. That's what happens. Thank you. From the graph, estimate how many months each year the population is below 17,500. How do we going to do that? Let's have a quick look at 17,500. Where do we think that's located? It's halfway of halfway, isn't it? It's 3/4 of the way up between 10 and 20. So I'm going to get rid of that bottom line. So guys, I'm going to delete that line there. Okay, so let's try it out. I reckon it crosses out at 4 years. 4 and 8, it's underneath. How many months each year? Okay, so let's do that. See the green line? That's how many months you're above. That's how many months you're above 17,500. See this green line here? That's also how many months you're above the green line. How many months is it in total? 4 months here and 4 months there, which is 8 months. Okay, guys. Sorry, guys. I did above when it should be below. So below is just 4 months, between 4 and 8. Gents, for homework tonight, question 14. And I'll